Hi everyone, welcome back to Math 11. So in this section, section 3.4, we are going to be looking at solving problems using acute triangles. And this is going to combine everything that we learned about acute triangles. So sine law, cosine law, and as well as primary trigonometric ratios, sine, cosine, tangent, and sometimes even Pythagoras. So I listed everything that we know already on the right side here. And also a couple of definitions right here. So we have a couple of definitions that hopefully you remember from grade 10. If you don't, let's take a look here. So angle of elevation and angle of depression. So angle of elevation refers to an angle that's always measured from a horizontal reference line. So for example, this is our horizontal. So if you go from the horizontal up, we call that angle of elevation. Let's say if you're standing on the ground and you're looking up on top of a tree or top of a mountain, you're looking at measuring, for example, angle of elevation. Let's say if it's the other way around, let's say you're standing on top of a mountain and you're looking down, let's say at the sea or something, then looking down from the horizontal, that's called angle of depression. So that being said, let's take a look at this problem here. So when you have some sort of trigonometric problem, you have all these options you can use, and normally there's probably more than one way you can solve it. So because we learned about sine and cosine law, how to determine which one to use first, what I suggest you do, see if you can use sine law first. If you can use sine law, then you may have to use cosine law, because sine law it's a little easier to manipulate. So at the top there's a little tip here. Use cosine law if you have either 3 sides or 2 sides with angle in between. Otherwise, use sine law. But when neither of those are possible to use, sometimes you may have to break it into right angle triangles. So if you have an acute triangle, you can always break it into two right angle triangles and then use primary trigonometric ratios to solve as well. So in this case, we have this display in the museum. We have 2 security cameras that must be adjusted to monitor the new display of fossils. So the cameras are mounted 6 meters above the floor, directly across from each other and on opposite walls. The walls are 12 meters apart. The fossils are displayed in cases made of wood and glass. The top of the display is 1.5 meters above the floor. The distance from the camera to the left to the center of the top of the display is 4.8 meters. So that's from camera A to the display down here. That's 4.8 meters. And then the distance from the other camera B is unknown. So we know that the camera is 12 meters apart, 6 meters on the walls. So we know all the information that's shown here. So the question is determine the angles of depression to the nearest degree for each camera. So these are the highlighted angles, so alpha and theta. So those are the 2 angles we need to find. Now to solve this question, we have a few options. We can use primary trigonometric ratios as a first option. So for example, if you look at camera A on the left side and angle theta here, we have a right angle triangle in which we know the hypotenuse and we know the opposite side. So if you already know 2 sides in a right angle triangle, you can find the missing angle. So let's try and use that first. So in this case, if you resketch this, let's say down here, here's what we have. We have right angle triangle. This is D. This point is not labeled. This is A here. This is 4.8. And this is 4.5. Now the reason this is 4.5 because the display case is 1.5 meters and the cameras are 6 meters above the floor. So 6 minus 1.5 is going to be 4.5. That's where that 4.5 comes from. So we're looking for this angle theta here. And again, whenever you do any questions involving triangles, always label them. So this is theta. This is going to be the opposite side. This is the hypotenuse side, and this is the adjacent side, which means we can relate the hypotenuse and the opposite side. So opposite and hypotenuse, that's going to be sine. So we can write sine of theta equal to opposite over hypotenuse. Okay, let's move it. And then we're looking for the angle theta itself. So theta itself is going to be the inverse of sine. So we can write theta equals sine inverse of the opposite over the hypotenuse. Which means now we can plug in the values for the opposite and hypotenuse to get the value for theta. So theta is going to equal the inverse of sine. So opposite here is 4.5 and hypotenuse is 4.8. So in this case, we're going to take the calculator, do 4.5 divided by 4.8, then take the inverse sine, and we get 69.63. I guess 64 if I round it to 2 decimals here. So that's the angle theta. So right away we found one of the angles using just primary trigonometric ratios. Okay, so let's take a look at this diagram again here. So now we know theta is 69.64. Now we can round this later to 70 degrees to the nearest degree, but for now we can leave it in case we need to use this value for another step. I can write down here that this is going to be 70 degrees when rounded. So let's take a look how we can find alpha here. So alpha again is going to be this angle of depression. And in alpha, on this triangle, right angle triangle on the right side, we know that this is 4.5. Now the 12 here, that's not from here to there, that's from the wall to the wall. So the 12 is actually this whole distance, right? So that's not just the from here to here. That's not 12, so we don't know what that distance is. So in the second triangle, we only know that opposite side is 4.5 meters. That's all we know. We don't know any other lengths. So what we can do here, we could use cosine law to find the missing side, because now if you look at this whole thing, we have a triangle that looks like this. We have a triangle that now we know angle theta, and we know that this side is 4.8, we know that this whole thing is 12, and now we know theta, which is 69.64. Okay, so, and we're looking for alpha here, we're looking for that side. So we can use cosine law to find the third missing side. Let's call it, textbook uses z, so let's stick with z. To find the third side, which then allows us to use another primary trig ratio to find alpha. So in this case, let's use cosine law to find z. Cosine law is right here, right? So pick any of these three lines. So normally it's shown with all three options, but really you just need to pick one of them. So let's say we're looking for side z, so the other two are going to be your b and c sides, right? So let's say z squared is going to equal to 12 squared plus 4.8 squared minus 2 times 12 times 4.8 times the cos. In this case, z would be corresponding to 69.64 times cos of 69.64. Okay, so the z itself is going to be the square root of all of this. So let's see what all of this equals to. So z is going to equal to the square root, and then let's punch all of this into the calculator and see what that equals to. So let's see, 12 squared plus 4.8 squared minus 2 times 12 times 4.8 times the cos of 69.64. That equals to 126.959, so on. So this keeps going. And then take the square root of this number, and we get 11.26. So the square root of this is 11.2, actually 7 if you round it up. Now that's in meters. So now we found size Z. So we know that Z now is 11.27 meters. Now this allows us to do next is, once you know this side here, it's 11.27. Now we have this side and we know this side. So we have the opposite from alpha and we know the hypotenuse for this triangle on the right. So now we have this scenario where we know two sides and we're missing one angle. So we know this is 11.27 and we know this is 4.5. And this is a right angle triangle. So in this case, again, label your sides. So this is our angle alpha, so that's your angle of interest. This is going to be the opposite side. This is going to be the hypotenuse. This is the adjacent side. So we need to relate the opposite and hypotenuse. So again, that's going to be sine. So we're going to write sine of alpha equal to opposite over hypotenuse. Okay, and then alpha is going to equal to the inverse sine of opposite over hypotenuse. So that means that for alpha, we're going to plug in sine inverse. Opposite is 4.5. Hypotenuse is 11.27. And see what that equals to. So 4.5 divided by 11.27, that's 0.399, and take shift inverse of sine, and we get 23.53 degrees. So that's our value for alpha. Now we have to round to the nearest degree, so this is going to be 24. So we found the two angles. So in this case we used primary ratios, sine, twice, and we also use cosine law because there was no other way to find that missing side. I guess there is another way. You could have found this little bit here using, let's say you could have used either cosine or tangent. Once you found this bit, then you can subtract from 12 and then you can find this length here and then use that to find the angle. But that would be pretty much about the same amount of work as using the cosine law. So a lot of these questions have multiple ways of solving them, but some of the questions are going to be a bit more shorter than others. So you had to kind of realize what's the fastest way to solve a question. And that's why we have all these tools at our disposal. Trig ratios, Pythagoras, sine law, cosine law. So you had to pick and choose basically which one you think would be the fastest way. All right, so that's our first question. So let's take a look at the second one. So the second question, we have Brendan and Diana. They plan to climb a cliff at Dry Island Buffalo Jump in Alberta. They need to know the height of the climb before they start. So let's say they have to figure out how much rope they need to bring. Brendan stands at point B. So Brendan's right here, point B. As shown in the diagram, he uses a clinometer, so that's a tool for measuring angles, to determine the angle ABC. So he's looking at this angle here. Now, this is the angle of elevation because he's standing on the bottom, he's looking up at the top of the mountain. So that angle he measures to be 76 degrees. Then he estimates the angle CBD. So CBD is this angle right here, which is the angle between, let's see, CBD is the angle between the base of the cliff himself and Diana, who stands at point D. So Diana is here. And he measures that angle to be 60 degrees. So then Diana estimates the angle CDB. CDB is this one right there, to be 50 degrees, which is between the base of the cliff, herself, and Brendan. So the question is, determine the height of the cliff to the nearest meter. Okay, so we're looking for basically the height here from A to C. That's the height of the cliff. So in this case, we have a right angle triangle. So the right angle triangle is ABC, and then we have an acute triangle, CDB. So if you look inside of the acute triangle, we know two of the angles, and we know the distance between Brendan and Diana, which is 60 meters. So we know one side and two angles. So here's what we know. Let's do a sketch of this triangle. This is a point D, point C, point B. This side is 60, this is 50, and this is 60 here. So we can find the angle C just by doing 180 minus, and that will allow us to use sine law or cosine law later to find missing sides. So let's do angle C is going to equal to 180 minus 60 minus 50 degrees here. So let's see, 180 minus 50 minus 60 equals to 70 degrees. So angle C is going to be 70 degrees. So this here is 70 degrees. So now we know all the inner angles. So whenever you have all the inner angles and you have one of the lengths, use sine law, because sine law is easier to use. So we're interested in joining these somehow, relating this bottom triangle to this right angle triangle upright, right? So we have to find this length CB. So we need to find CB, which is, again, it's going to be that. So it's going to be lowercase d in this case. So let's label it as lowercase d as our unknown that we're trying to find. So for this, let's use sine law. So we're interested in the side length, so I'm going to write the side length on the top, d, over the sine of capital D. And then we have one length given, which is lowercase c here, and this would be lowercase b. So we're going to relate the side that's given, so it's going to be lowercase c and sine uppercase c. All right, so we know this, we know that, we know that. So the only unknown is the lowercase d. So let's solve for d, which basically just means cross multiply by sine d. So we get sine d multiplied on the top, so we end up with c times sine capital D over sine capital C. Plug in the numbers. So c is 60. Then we have sine of angle C, which is 70. Oh, sorry, D, not C. So angle D is 50 here. And angle C is on the bottom. So sine of angle C is sine 70. Okay, so punch all of this into your calculator and see what you get. So we have 60 times sine of 50 divided by sine 70. So we get 48.9 meters. So that's that length CB. Okay, so now we know the length D or CB. We can use that information and relate it to the other triangle ABC. So now we have this. The other triangle looks like this. Okay, which is a right angle triangle. And now we know this is point A, point B, point C. Now we know this length here, which we found to be 48.9. So this is 48.9 meters here. And we also know the angle is 76 degrees. So even though it's kind of looks like it's not a right angle triangle, it's just because it's kind of in perspective here. So based on this, we can find the height. So the height here is going to be, let's call it lowercase h. So if you're looking for the height, that's going to be the opposite side. And you have the adjacent side if this is your angle of interest here. So adjacent and opposite is going to be tangent ratio. So you can write tangent of angle, let's say theta, equals to opposite over the adjacent. All right. Now we're interested in the actual value of the opposite, which is the height. So let's plug in the values of what we know. So the tangent, 76 degrees, equal to the opposite, which is the height, over the adjacent, which is the 48.9 that we found. So the height, you had to cross multiply. The height is going to equal 48.9 times the tangent. Okay? So let's see. This times 48.9 times tangent of 76, I get 196.177 meters. So we're going to round this height to the nearest meter. So the height is about 196 meters. So almost 200 meters climb. So you definitely want to have enough rope if you want to climb that high. Or even, I don't know, I'm not like climbers, but definitely you need to have enough. So there's a way where we use sine law in combination with trig ratios to find the answer to this question. I'm sure there's probably other ways you could have done this. You probably could have used cosine law to find the missing side here, which is possible, but again, that would be a bit more work because cosine law is a bit more tricky to use, but sometimes you have no choice. So here we used just trig ratios and sine law. So as a reminder here, I kind of took a clip from the textbook, what you need to know from this section, and this is a summary of how you use sine and cosine law, when to use it, right? So for example, if you have two sides, an angle opposite to one of the sides, you can use sine law, okay? If you have two angles and a side, like either here or here, you can use sine law as well. But if you have two sides and a contained angle, so contained means between the two sides that are given, you have no option but to use cosine law. In the last case, if you have all three sides but no angles at all, then you definitely have to use cosine law. Sometimes you can break it into two right angle triangles and use primary trig ratios as well. So like in these two questions, we use trig ratios in combination with sine law and cosine law. Okay, so for practice, make sure you do the questions 1, 3, 5, and 11 from section 3.4, and make sure you go over the reading. So read through the examples on pages 140 to 146.